Today we'll learn about the combined gas law and solve a practice problem. Let's say we have a gas in a container and we want to find out how its volume changes when we change the pressure and temperature. Let's start with our initial conditions. Here we have a container of gas at our initial state. The initial pressure P1 is 2 atmospheres, the initial volume V1 is 3 liters, and the initial temperature T1 is 300 Kelvin. Now, we change the conditions to a new state where the pressure P2 becomes 4 atmospheres and the temperature T2 becomes 400 Kelvin. We want to find the new volume V2. To solve this problem, we'll use the combined gas law. The combined gas law states that the ratio of pressure times volume divided by temperature remains constant before and after any change. On the left side, we have P1 times V1 divided by T1, which equals P2 times V2 divided by T2 on the right side. To find V2, let's rearrange the equation. First, multiply both sides by T2. Then divide both sides by P2. This gives us our formula for V2. Now, let's plug in our values. P1 is 2 atmospheres, V1 is 3 liters, T2 is 400 Kelvin, T1 is 300 Kelvin, and P2 is 4 atmospheres. Let's solve this step by step. First, multiply the numerator. 2 times 3 times 400 equals 2,400 liter Kelvin atmospheres. Then multiply the denominator. 300 times 4 equals 1,200 Kelvin atmospheres. Finally, divide 2,400 by 1,200. Therefore, the new volume V2 equals 2 liters. This makes sense because when we doubled the pressure, the volume should have been cut in half. But since we also increased the temperature, which causes expansion, our final volume is 2 liters instead of 1.5 liters. Remember, pressure and volume are inversely proportional, while temperature and volume are directly proportional. These relationships are what make the combined gas law so useful in understanding how gases behave under changing conditions.